Welcome to Ontario Nature's tutorial on using the software InVEST to calculate carbon stocks. In this introductory tutorial, I'll walk you through each step, including obtaining carbon pool datasets, how to clip this information to your site, how to input this data into InVEST, and how to interpret the results. We're going to be working with the following applications: ArcGIS Pro with the Spatial Analyst license, Microsoft Excel, and InVEST. The link to download InVEST can be found in the description below, and it can also be found on the Natural Capital Project website. Download the most recent version of InVEST here. The carbon storage and sequestration model is one of many models within the InVEST application developed by Stanford University as part of their Natural Capital Project. The purpose of this application is to map and evaluate natural services, including carbon storage. The carbon storage model requires a map of land cover types for your area of interest and a table of carbon pools. Let's first focus on obtaining this map of land cover types. You can use your own land cover data or find this data online. In our example, we'll download the Ontario Provincial Dataset from Ontario GeoHub, which is at a 15-meter resolution. You'll first need to click Open Document, and then click Open, and the files will start to download. Once they're downloaded, you can then unzip the files. Let's start by creating a new map where we'll work on our carbon storage assessment in ArcGIS. You can add the land cover data first, and I've saved it here in Downloads. Then you can add a shapefile of your area of analysis. For this example, I'm going to be working with the Black Bay Peninsula, which is a candidate protected area near Thunder Bay, home to many species at risk, which Ontario Nature and several nature groups would like to see permanently protected. Next, we need to clip this provincial dataset to our area of analysis. So we'll use the tool Extract by Mask. So we will select the land cover file as our input raster and the Black Bay Peninsula as our feature mask data. And then we can save it within the geodatabase. And then we'll click Run. Now that the provincial dataset layer has been clipped to Black Bay Peninsula, we can turn off this provincial dataset layer. And we'll open up the attribute table. And we can notice that the information on land cover names is not included, so we'll add that in as a field. So we click Add, enter LULC_name as the title, click Save, and enter the land cover name that corresponds to the value provided in the original dataset. And since we edited this table, make sure to save your edits. InVEST requires the land cover information to be a TIFF file, so we'll export this raster as a TIFF. And be sure to change the output format from grid to TIFF. Now that our land cover file is complete, we'll need to create a table of carbon pools, like in the example on my screen. The values in the carbon pool table represent the average carbon storage value of each land cover class included in your map. These estimates can be based on published literature or existing datasets. If you're using published data, you can simply type in the average carbon storage value per land cover type for each carbon pool. Make sure that these values are in megagrams per hectare, as this is the unit that InVEST uses. Although, note that 1 megagram per hectare is the same as 1 metric ton per hectare. You can also use existing datasets to obtain carbon pool data. I'm going to use above ground and below ground biomass data from the Oak Ridge National Laboratory Distributed Active Archive Center. You'll need to create a free account, but after that you can download both of the datasets here. We sourced soil organic carbon data from the National Carbon Map project created by World Wildlife Fund Canada and McMaster University's Remote Sensing Lab. You can access the information about their project here and view an interactive map of carbon stocks across Canada at a 10-kilometer hexagon resolution. The authors have published their soil results separately, and we can download all of the data here on Figshare. Once we've downloaded our carbon pool data consisting of above ground biomass, below ground biomass, and soil organic carbon, we'll go to our downloads folder and unzip them. So navigate to wherever your downloads folder is. You may need to refresh. Open up the folder that has the data that you just downloaded, and we'll add both the above ground and below ground biomass raster datasets. Next, we'll add the soil organic carbon dataset that's downloaded from WWF Canada and McMaster University. Note that this dataset has several files with an uncertainty layer and soil at different depths. So we will want to add the soil carbon at a depth of 1 meter. Since these are global and national datasets, clipping them to our area of analysis will make them easier to work with. We can use the Extract by Mask tool again. In this case, select each of the carbon pool datasets as the input raster, and again we'll use our area of analysis as the mask data. And once we've clipped those datasets, we can remove these large datasets from the workspace. InVEST calculates carbon storage in megagrams per hectare, so we'll need to verify whether these datasets are provided in megagrams per hectare. The above ground and below ground biomass dataset is provided in megagrams per hectare, but we'll notice that the scaling is 0.1. If we take a look at the accompanying scientific article, we can see that the map was scaled by a factor of 10 to reduce file size. To convert the units, we can use a tool called times. So we'll select the above ground biomass dataset as the input raster, enter 0.1 as the value that we're multiplying by, and save it with a new file name. And we'll do the same process for below ground biomass. And we'll remove these older files that we created from the workspace so that we don't get confused. And we'll check the soil carbon data set. So we can see here that the units are in kilograms per meter squared. So we can fix that again with the times tool. So 1 kilogram per meter squared is equal to 10 megagrams per hectare. And again, we can remove this older layer. To calculate the amount of carbon stored in each carbon pool per land cover type, we'll be using a tool called Zonal Statistics as Table, which summarizes the value of a raster within the zones of another dataset. This will summarize the values of each carbon pool within the zones of each land cover type to give us an average value of above ground, below ground, and soil biomass at each land cover type. If you don't have this tool, you might be able to use the Summarize Within tool. If this is the case, you would need to convert the land cover and carbon biomass layers to shapefiles. In the Zonal Statistics as Table tool, our input raster is the land cover dataset. And be sure to select the land cover name as the zone field. Next, the input value raster is what we're going to summarize. In this case, we'll start with above ground biomass. And we'll save it within the geodatabase. And click Run. And we'll complete this whole process for the other two biomass datasets. And the table should be provided on the left side at the bottom. We'll open that up. And we can see a mean value for each of the land cover types in Black Bay Peninsula. So we will take all of this data, be sure to click Switch so that all of the rows are selected, and click Copy. And we'll put it into an Excel file to create our carbon pool table. And paste it in here. So the only values that we need to keep are the land cover names and the mean value. So we can delete everything in between. And we'll complete this process for the other two tables that have been created for below ground and soil biomass. Next, we'll need to format this table so that InVEST is able to understand what is in each cell. So the first column we'll call LU code, or land use code. The next column header can remain the same, LULC underscore name. The first one should be called C underscore above, or carbon in the above ground biomass. Next is C below. The next one is C underscore soil. And the last one we can call C underscore dead. InVEST allows you to include dead wood, but we were not able to find a provincial or national data set of dead wood. If you don't have that data, you can just enter 0 for each of those land cover types. The next thing we'll need to verify in our table is that LU code matches the value used in your land cover file. So we'll go back to ArcGIS and open up the attribute table of our TIFF file. The first column is the field ID provided by ArcGIS. What InVEST will be using is this value that was provided from our original layer. So we will switch the selection here and copy this data. We'll paste it here in Excel, verify that all of the land cover names match up with the ones that we already have written in the table. That way we can just move these values over and replace what was already there. You may need to edit these values. For instance, the carbon datasets that we used only evaluated terrestrial carbon, so there shouldn't be any carbon stored in clear open water based on this model. So we'll just enter 0 for every carbon pool for clear open water. There's also likely to be no carbon stored in community or infrastructure, so we'll enter 0 here as well. Depending on what land cover dataset you use, you may need to account for any other or missing data. So we can do that by adding a row in the Excel file. Finally, InVEST requires that the table be saved as a CSV file, so I'll do that now. Now that we have our land cover file and carbon pools table, we'll add this data into the InVEST model. So we'll click on the carbon storage and sequestration model. First, we'll need to choose a workspace or where the output files will be saved. I'm going to save this in the same place that I've saved the input data, in a new folder. Next, under current LULC is where we'll add the map of land cover types. And under carbon pools is where we'll add that table of carbon pools. Once you've added the land cover file and the carbon pools table, you can click Run. Now that the model is complete, we'll open up the output in ArcGIS. InVEST will create a TIFF file as the output called TOT_C_CUR, which stands for the total amount of carbon that is currently stored in that area. And we'll add that to our workspace. And I'll just turn off all these other layers that we don't need anymore. So this is what the carbon stock map looks like of the Black Bay Peninsula. You can change the symbology so that it's easier to see where the high carbon areas are. So in this example of the Black Bay Peninsula, we can see here at the top, there's some areas with lots of carbon. And if we look at our map of land cover types, we can see that this area is a fen, among other types of wetlands, which store high amounts of carbon. The last step in this tutorial is to calculate the total and mean amount of carbon stored in this site. To do this, I'll use the Zonal Statistics as Table tool again. Select the shapefile of your area of analysis as the input raster or feature zone data. So I'll select this shapefile of the Black Bay Peninsula, since there's only one polygon and it will calculate the entire carbon stored in the Black Bay Peninsula. We'll select FID or field ID for that one polygon that we're calculating with. And as the input value raster, or what we're summarizing, we will select the output file. And click Run. Once that's done, we'll scroll down to the table and open it up. and we can see here under Sum the total amount of carbon that's stored in megagrams or tons. In this case, it is 32 million tons of carbon. To find the mean value across the entire site, we can take this total amount of carbon and divide it by the total area of Black Bay Peninsula in hectares. So we'll input the total amount of carbon stored first, divide it by the area of Black Bay Peninsula, which I've previously calculated and is around 56,000 hectares. And we can see that on average, Black Bay Peninsula stores roughly 585 megagrams or tons of carbon per hectare, based on this InVEST model. In this tutorial, we downloaded carbon pool datasets from various sites, clipped these datasets to our site of interest, in this case the Black Bay Peninsula, edited and input the data into InVEST to calculate the amount of carbon stored in our site, and lastly, we interpreted the InVEST results. Using InVEST and other models to measure carbon stocks can help with a wide range of conservation projects. However, like all models, this model has limitations, and using different carbon datasets can lead to different results. I encourage you to always check with local data and knowledge and to compare your results with other literature. If possible, field measurements from your area can be used to inform the values used in your carbon pool table or to validate your model. This concludes our tutorial on assessing carbon stocks using InVEST. Thank you for watching, and if you have any questions about InVEST, you can refer to the user guide created by Natural Capital Project or post on their community forum. The links have been included in the video description.